Let's denote the given series by S. The first objective is to find the general term of the series. So we start by considering the positive value of the coefficients of each of the terms, which is 3, 8, 13, 18, and so on and so forth. And let's consider a series which is made up of these terms. Let's denote it by P. So P is equal to 3 plus 8 plus 13 plus 18 and so on and so forth. And let the nth term be Tn. Now we can write P again by staggering each of the terms by one position. So we get 3 plus 8 plus 13 and so on and so forth, plus Tn. Subtract the two expressions. So we get 0 on the left hand side. On the right hand side we have 3 plus 8 minus 3 is 5, 13 minus 8 is 5, and so on and so forth. The n minus 1th term is Tn minus 1. The last term is minus Tn. We take the last term to the left hand side. We get Tn is equal to 3 plus 5 plus 5 and so on and so forth. And there are n minus 1s such terms, all equal to 5. So the value of Tn is 3 plus 5 times n minus 1, which is equal to 5n minus 2. Therefore, the general term of the given series can be expressed as the 3, 8, 13 and so on can be expressed as 5r minus 2. There is a minus sign in every alternate term, so that can be expressed by minus raised to the power r plus 1. All this multiplied by n choose r minus 1. And the value of s is obtained by summing this expression, where r ranges from 1 to n plus 1. Now let us denote r by j plus 1. So when r is equal to 1, the value of j is 0. When the value of r is n plus 1, the value of j is n. Therefore, the sum s can also be denoted by summation j going from 0 to n. 5r minus 2 can be written as 5 times j plus 1 minus 2. Minus raised to the power r plus 1 can be denoted by minus raised to the power j plus 2. And n choose r minus 1 becomes n choose j, which simplifies to summation j going from 0 to n. 5j plus 3 is the first term, multiplied by minus raised to the power j times minus raised to the power 2. Minus raised to the power 2 is 1, multiplied by n choose j. And this expression can be broken into two components. The first being 5 times summation j going from 0 to n minus raised to the power j times n choose j. And the second term is 3 times summation j going from 0 to n minus raised to the power j times n choose j. Let's denote this expression by 1. Now let's consider the standard binomial expansion for 1 plus x raised to the power n, which is equal to summation j going from 0 to n choose j times x raised to the power j. And if we set x is equal to minus 1 in this expression, the left hand side is 0, the right hand side is summation j going from 0 to n minus raised to the power j times n choose j, which we notice is the second term in the original expression for s in equation 1 above. Now we once again use the binomial expansion of 1 plus x raised to the power n which is equal to summation j going from 0 to n, and choose j multiplied by x raised to the power j. Differentiate both sides with respect to x. The left hand side we get n times 1 plus x raised to the power n minus 1. And on the right hand side we get summation j going from 0 to n. The differential of x raised to the power j is j times x raised to the power j minus 1 times n, choose j. Again set x is equal to minus 1. The left hand side becomes 0. The right hand side is summation j going from 0 to n. J times minus raised to the power j minus 1 times n, choose j. Multiply both sides by minus 1. We get summation j going from 0 to n. J times minus raised to the power j times n, choose j, is equal to 0, which is the same summation that is found in the first term of the original equation 1. So the value of s is found by going back to equation 1 and using results 2 and 3 and substituting them in equation 1. S is equal to 5 times 0 plus 3 times 0 adds up to 0, which is the required result.